Good morning to all. Today we are going to see about the structure analysis 1 that is presented by myself, Akila Priyadarshini from the Department of Civil Engineering, VSB Engineering College, Karur. And by studying this subject, the students will learn about the basic concepts of how to analyze the structure. By the course outcomes of this subject will be the analysis of pin-jointed frames and space frames by the different methods. In the unit 2, they will cover with slope deflection methods where they will include the continuous beams as well as the rigid frames. And in the third unit, they will go on with the next method of moment distribution where it comes with the understanding of continuous beams as well as the rigid frames with sway and without sway. And then the indeterminate stress pin jointed frames and will be determined by using matrix flexibility method, and the fifth unit will be the matrix stiffness method. In this also they will determine with the both continuous and rigid frames. And the syllabus of first unit will be this one, and this is the where they will determine the determinate structure and indeterminate structure, and they will find the difference with this. With this they will start analyzing with the determinate stress, and then they have the methods of 2 months, which is they can find out by using the method of joints and then by using the method of sections. With respect to this, they can find the deflection at the pin jointed frames, where the pin jointed frame is that it is of straight member which is connected to the horizontal or a vertical member to provide stability. And then the lack of it will be the errors that is caused during the design and then the erection. And the change in temperature includes the tension coefficient with where the member is of exposure to temperature. It may sometimes expands due to its temperature changes. The length will vary. And then where the application of space stress is done, that is mostly of industrial areas. The reference textbooks will be the structure analysis by Vaidyanathan and Dr. P. Perumal and the Bhaviketti of structure analysis volume 1 and 2. Before studying the structure analysis 1, they need to know about the engineering mechanics basics, which includes the concurrent, non-concurrent, and coplanar forces, and the equilibrium of rigid particles, and then the free body diagram, which they will find the forces with this, and then the strength of material, where they will learn what is stress and what is strain, and the Hooke's law, elastic contents, and the drawing of shear force and bending moment diagrams, and the basic conceptual structural elements, where it is of types of loads and load combinations, and the basics of trigonometry and differential equations will be needed for learning structural analysis 1. And what is the need of learning the structural analysis of being a civil engineer? The structural analysis will be the backbone of civil engineer, and it predicts how the structure behaves on various loading and how it will be safe or economical and how long it will durable. Everything is under the design of structure analysis. And first it ensures the safety and and then it is of economy and serviceability, and fourth one will be the durability, and fifth one optimization, and sixth one is the prediction of behavior. In safety, they ensures all possible variations that avoid failures and protects lives and properties. And while coming to the economy, they will give you the under design concept and over design concept, which will lower the construction cost. And then the serviceability, which provides the comforts to the vibrations and provides the proper functioning of the structure. And then durability, and in this it will include the environmental effects and how long the structure is durable is predicted in the durability sectors, and that is what is done by using the change of temperature sections and stress. And optimal design, it is of more efficient design and will help for the structural elements to withstand for a longer life. And the prediction and how long the structure will withstand, and by considering the wind loads, live loads, and the seismic loads, and the change of temperature, etc., will be considered here. And this image shows how the syllabus is going on, and the structures are analyzed by using the structure analysis syllabus is based on the first unit is of pin jointed, and second one is of continuous slope deflection, method where they will learn continuous beam and rigid frames. With respect to this, they will draw the shear force and bending moment diagram. And then the moment distribution method of continuous and both the rigid frames, and they will learn about the iteration methods to find out the moments that is carried over toward the beams and frames. And then the flexibility, how long the material or the structure is flexible, is determined by using this method. And these are all the advanced methods by using the softwares they use. And then the next one is the direct stiffness method. They will use by matrix, and they will have the continuous chips, and they will find the redundancy, and the deficiency is highly predicted there. How we can say it is a determinate structure in which all the external forces, reactions and internal member forces are calculated by a static equation, which is M is equal to 2J minus 3, where M is of member and J is of joints. And then indeterminate structures. Indeterminate structure is where the number of unknowns and internal forces exceeds the number of available static equilibrium. It is what is indeterminate structure, and it is what found out by M is greater than 2J minus 3, where M is of member and J is of joints and R is of reactions. The need to analyze a determinate structure. By analyzing the determinate structure, we can find the support reactions and the internal forces, which includes the axial force, shear force, and bending moment. Where axial force is of forces that act in the longitudinal axis, and the shear force will be the summation of all forces, and the bending moment will be the load that acts over the certain length. That is what is bending moment, and they can evaluate the deflections and how the rotations will be is predicted, and it will ensure the safety and serviceability, and it will achieve the economic design. And by using this indeterminate structure, we can have a following advantage. By we can reduce the deflection and increase the structural safety, and it provides a more economic member sizes, and that will reduce the economic cost. And disadvantages, the analysis will be complex and and large structures cannot be done in a easy manner, and it's highly sensitive to temperature effects and support settlements. And the method of joints. The method of joints to determine the force in each member, and by applying the equilibrium of equation at each joint. By the method of joint, we can find the forces that acts on each joint by the equilibrium equation. The support reactions are found out by equilibrium equations, where it is considered as summation f of x is equal to 0, summation f of y is equal to 0, and the moment summation m is equal to 0. While by using this method, we have to select the joint which is of from A or D. We have to select the joint which is of from A or D. And while selecting the joint A, we have to start drawing the free body diagram and the forces that acts on the joint A. In A, we have a horizontal force at AX, and the horizontal reaction as AX, and horizontal vertical reaction as AY, and the forces acting as FAC and FAB. And they equally have the vertical force as F sine theta, and vertical force as F sine theta, and horizontal force as F cos theta. Likewise, the FAB will have the horizontal force as F cos theta. And by using the equilibrium equation, we found out the f of ax and f of ab. By applying this, we can find the next joint, and we can go to the adjacent joint, that is of joint D. And likewise, we can add each and every joint and find out the forces in the equilibrium equation. And then the deflection of pin jointed frames. The pin jointed frames or truss are equal to the displacement, and that is to the original load, original portion due to the external change, which includes the temperature changes, fabrication errors, and the support settlements. In this, the unit load method is used. In this, the unit load method is used where the loads are removed and the unit load, which is of 1 kilonewton, is introduced in the all joints. And then by using this formula, the deflection is found. Where the deflection is found out by using del is equal to summation of capital P small p into L divided by A into E, where capital P is of force force member actual loading, where the problem is given with the actual loading, no, that loading will be considered there, and the small p will be the unit load. By using the unit load, we can calculate either by using a method of joints or by using a method of sections. We can use in such factors the small p is considered, and L will be the length of member, and A will be the cross-sectional area, and E will be the Young's modulus. And lack of fit. And lack of fit is the initial error that is due to the fabrication and erection inaccuracy, and that causes due to the longer and shorter span than its required length. While considering while the erection or fabrication, the accuracies may occur, and such cases this lack of fit will be considered, and it causes displacement of joints, and the force distribution among the members will be vary, and it may lead to the structural instability. And change in temperature method or of tension coefficient, it includes when the temperature of a stress member changes, the length will be changed, and that is what is done by using a joint displacement or produced, and it is found out by using sigma t is equal to alpha L into del T. And application of space stress. The application of space stress is a three-dimensional framework in which it is composed of a straight member, and that was connected with a pin joint and the load acting at the joints. It is mainly used in industrial areas where they have large spans, and we can't use any concrete structures. They will use this space stress, and where the height strength to the weight ratio will be high, and the torsion, they will have a good resistance to the torsion effects, and um, and they will aesthetically gives an architectural appearance. And this image shows the space structures in which the length ratio weight height and length ratio will be high, and it gives a very um, architectural space for the running of an industry and for a large auditorium or a mall. By learning this unit, they will clarify which will be the determinate structure and which will be the indeterminate structure, and they will analyze where we can analyze the method of joints and method of sections and determine the deflection of pin jointed frames, and then they will provide with the lack of fit and the temperature behavior is understood by learning this unit.